September 30th, 2012, Florence, Italy, a hotel conference room. The world's best AI researchers wait for results. Every team expects a winner around 26% error rate. That's just where the field was. Then one number appears on the wall, 15.3%. The room goes silent. Not polite silence. The silence of people recalculating everything they thought they knew. That gap wasn't incremental progress. It was a cliff. And by the end of this story, you'll understand why that single number changed what it means to be human in the modern world. To understand that moment, go back 70 years, 1956. Dartmouth College. A handful of researchers invent a new field. They call it artificial intelligence. Their prediction: a machine like the human mind, maybe 10 years away. They were off by 60. What followed was brilliant failure. Systems that worked in labs collapsed in the real world. The AI winters hit twice. 1974, then doggone 1987. Funding vanished. Labs closed. The words artificial intelligence became so toxic that researchers rebranded their work as machine learning just to get grants. But one man never stopped. Geoffrey Hinton, a British researcher at the University of Toronto. For 4 decades, he believed machines could learn by adjusting connections, the way neurons in a brain do. His colleagues moved on. 2 winters came and went. Hinton kept working. Standing at his desk, his bad back meant he never sat. He filmed lectures lying on his floor. 40 years wrong in everyone's eyes. Still going. Back to that number, 15.3%. The system that produced it was AlexNet, built by Hinton's PhD student, Alex Krzyzewski. Here's the remarkable detail. It ran on 2 gaming GPUs, the kind you'd buy to play video games. Total cost, roughly $1,000 in a bedroom. In Toronto, no supercomputer, just 2 graphics cards, 14 million labeled images, and a deep neural network learning to see. 3 ingredients finally aligned. Enough data, enough compute. And the architecture Hinton had always believed in. 3 months later, Google bought Hinton's lab. 3 researchers. Near zero revenue. $44 million. But AlexNet wasn't the real breakthrough. What it proved was that scale works. That the brain inspired ideas the field had abandoned. They were right. And the next leap was already coming. 2017, Google Brain, 8 researchers with a radical idea. Every AI language model processed words in sequence, one by one, left to right. Slow, hard to scale. Their idea: stop. Let every word see every other word simultaneously. Let the model decide what matters. They called it attention. The paper, attention is all you need. 173,000 citations. Top 10 most cited papers of the 21st century. And then, all 8 authors left Google. The paper written inside Google, funded by Google, became the engine that powers every company now competing with Google. Every large language model today, GPT, Claude, Gemini, runs on their architecture. Google published its own disruption. November 30th, 2022, OpenAI releases a research demo. They expect a few thousand curious developers. Sam Altman tweets about it casually. The servers fall over immediately. 1 million users in 5 days. 100 million in 2 months. Instagram took 2.5 years to reach that. Netflix, 3.5. ChatGPT did it in 8 weeks. Then something unexpected. The model began doing things it was never trained to do. Writing legal briefs, passing medical exams, generating working code from plain English, capabilities that appeared at scale, not gradually programmed in, just emerged. No one predicted them. Researchers still debate what they mean. In 2024, Geoffrey Hinton received the Nobel Prize in Physics. 40 years of being called wrong. The committee had effectively declared he was doing physics all along. 70 years of failure, 12 years of breakthroughs. Think about what it means that intelligence can be learned, not programmed, not designed rule by rule. Shown enough examples, given enough connections, something emerges. We still don't fully understand why. The people who built this were defunded, dismissed, called foolish, and then they changed the world. What ideas are we dismissing right now? Deep in a tropical forest, a carpenter ant is climbing a plant stem against its will. Something has hijacked its legs, its jaws, its direction. A parasitic fungus called Ophiocordyceps threads through its muscles, reading chemical signals, issuing commands. The ant climbs to exactly the right height, the right angle, and clamps down. No brain, no nervous system, just chemical signals and perfect control. How does a single organism navigate the architecture of another creature's mind? Title: Suggestions. 5 options. 1. The Accidental AI Revolution. How a bedroom experiment changed everything. 2. Why AI was dead for 40 years, then won the Nobel Prize. 3. The paper that 8 researchers wrote, then fled from. 4. From bedroom GPUs to 100 million users in 60 days. 5. The 70-year bet that transformed human intelligence forever.